Okay, hello everyone. I'm Tori from Felicity Solar. So I'm the guy to be the lecturer. So today we're going to share something about the wire size and the circuit breaker selection. So here we're gonna start. Here are the contents. We will divide them into 4 parts: the wire selection, wire cross-sectional area comparison table, and the circuit breaker selection, and the example introduction. So here, the first part is about the wire selection. So why is necessary to select the appropriate wire size? When we talk about the size of the wire, we are talking about the cross-sectional area. So selecting the appropriate wire size for the specific application is essential to ensure the efficient and the safety operation. So first of all is the safety. If we buy the small size of the wire, when it connects to the electrical appliances with large power, and then the wire will generate heat, and this may cause the current leakage and the overload. And then the electric appliances or wires will be burned up and a short circuit happens, and it could be very dangerous. But what if we use a bigger one? Is a bigger gauge wire better? Actually, no. It depends on what we need. So in general, thicker wires can carry more current with less resistance, which may be better for certain applications such as higher power electronics or long-distance power transmission. However, thinner wires are more flexible and may be more suitable for other applications such as wiring in tight space or for low-power devices. Therefore, we should do the calculation first. We need to know the current, and according to the power of the inverter and the voltage of the appliance, then we choose the right size of the wire to avoid the damage caused by the small cross-sectional area, or we're gonna avoid the waste of money, because the thicker the wire, the higher the price it will be. And then here is the wire cross-sectional area comparison. If it's 24, it should be 2. If it's 30, it should be 3.3. If it's 40, it should be 5.4. If the current is 59, then the size of the wire should be 8.3. If it's 48, it should be 13.2. And here, one more thing should be mentioned is about the AWG. So if you are living in a region that using the American standard, then you should check this. Check the AWG. But if you are not, you can just check this. And we go on. Here is the continue table. If the current is 110, then the wire should be 21.1. If it's 151, it should be 33.6. If it's 191, it should be 42.4. If it's 241, then the size should be 53.4. If the current is 210 ampere, then it should be 67.5. If it's 245, then the size of the wire should be 85.1. You should write a note to remember all this. Here, let's check it again. Okay, now we're gonna move on. The third part is about the circuit breaker selection. So here it is a picture of a circuit breaker. And first, we're gonna say about the function of the circuit breaker. A circuit breaker is a component often used for circuit and device protection, essential in the operation of a circuit or engine, because it will interrupt in the flow of the current to make sure that the maximum of the current will be within the safety range. So if the rated current and the rated voltage of the circuit breaker are too small, it will cause frequent trip, and it's not good for the use of the device. And if they are too large, the breaker cannot trip at the right time and protect the devices. So it will be useless, and it could be very dangerous actually. Therefore, it's very important to choose the right circuit breaker. And here are the principles to choose the right circuit breaker. The first one is the circuit breaker rated voltage should be larger or equal to the wire rated voltage. And second point, the rated current of the circuit breaker should be larger or equal to the calculated load current of the wire. And third, the limit breaking capacity of the circuit breaker should be larger or equal to the maximum short circuit current in the line. And fourth, the automatic switch instantaneous or short delay trip setting current with a single phase to ground short circuit current at the end of the line, not less than 1.25 times. But usually you only need to pay attention to the first point and the second point, because for the third point and the fourth point, you need more professional knowledge and the professional devices to measure. So it's kind of complicated. All we need to do is to pay attention to the first point and the second point, the rated voltage and the rated current. Okay, we go on. Now it's about the example introduction. In this part, we're going to do the calculation for you to better understanding how to calculate the current and choose the right size of the wire and the circuit breaker. So to configure a 20,000 system, here is the list of the material we need. First, we will use one inverter, that is the IVPN 148. And then we use two lithium batteries, LPBF 48200H. And we use 12 solar panels. And the ISC of the solar panels is 12 ampere, and the VOC is 47 voltage. And we will use one PV combiner box and one battery combiner box and a few wires. Here is the whole system. As you can see here is the inverter, and here are the two batteries. And this one is the battery combiner box. This one is the PV combiner box. And here is the load. And here is the solar panels. Please pay attention to the layout of the solar panels. As you can see, there are 3 strands and 4 parallel. This is a very important information. We need them like later. And here, I need you to calculate the current, because we are going to choose the size of the PV wire. But before we choose the wire, we need to know the current of the PV. So here are the information you may need. The ISC of the solar panel is 12A, the 12 ampere, and the VOC is 47 voltage. And the system is configured in 3 strands and 4 parallels. So I need you to calculate the current. I'll give you 1 minute, and 1 minute later, we'll do the calculation together. But before that, I hope you to do that by yourself. to calculate the PV wire, we need this info. So 20 more seconds. Okay, do you finish? Now we're gonna do the calculation together. So here you can see the ISC is 12 ampere and is in 4 parallel. So the current should be 12 ampere times 4. So it equals to 48. Do you did the right calculation? Here it is, 12 times 4. And here, now we check the table. So 48 is here, between 40 and 59. And as we said, if you choose the smaller size of the wire, it can cause danger. So we will choose the bigger one, the 59. Then the size of the wire should be 8.3. You see? So according to the current and by the table, it's concluded that a wire with a cross-sectional area of 8.3 is the wire we will choose. And then we're going to do more calculation for you to better understand that. Here we're going to do the calculation of the load wire. So still the same, I need you to do the calculation that how big is the current of the load wire. And then by the table, we will find out the size. So the IVPN 148 has a power of 10,000 watts and a load rated voltage of 220 voltage. And by this information, I need you to do the calculation to find out the current. So I'll give it another 1 minute. Okay, it's about the time. Do you finish? Okay, here we can see the power is 10,000 watts and the voltage is 220. As we know, here power is the voltage times the current. So how we do the calculation? It should be like this, right? 220 divided into 10,000. And the number will be around 46 ampere. So now we know the current is about 46 ampere. And now we check the table. You can see 46 actually is close to 48. just like the PV wire. So we should choose the same wire, like 8.3. You see? So first, we should do the calculation to find out the current, and then we will see which kind of wire we should use. And there is a note. You should notice if the load is bypassed with the load, then the manual actually already told us the current of the bypass with load is 63A. And 13.2 millimeters square wire can be selected according to the table. So if the load is bypassed with load, then you can just use the 13.2, the size. You don't need to do the calculation. But if it's non-bypassed with the load, then you have to do the calculation to know the current first. Okay? Now we're going to move on. Now we are going to talk about the circuit breaker selection. Usually our inverters, they have a circuit breaker inside except the IVEM. So there is a circuit breaker at the AC output of the IVPM inverter. But what if you use like another inverter, other brand, they do not have the circuit breaker inside? Then we should install a circuit breaker for the sake of the safety. So here, we're gonna do the calculation together to learn how to choose the right circuit breaker. Since the IVPM output voltage is 220 voltage, so the voltage of the circuit breaker, it needs to be 220 voltage or above. That's the principle. Do you remember? The circuit breaker rated voltage should be bigger or equal to the wire rated voltage. And then, by the calculation, we can know the current is around 46 ampere. So, at principle 2, the rated current of overload trip of the circuit breaker should be 48 or above. That's the principle 2. That's we need to pay attention to the voltage and the current. Here is a picture of the specification of the circuit breaker. So here are two spots you need to check before you buy a circuit breaker. First one is here. Here means the rated current of the overload trip, and it should be bigger than the current. And second one is here. Here is the voltage. So the rated voltage of the circuit breaker should be bigger than the output voltage. Now you see, just by the two principles, it is easy to choose. Okay, now we're gonna move on. Here is the picture of the whole system. As you can see, here we use the IVPM inverter. Actually, it has a circuit breaker inside, but if you use another inverter that has no circuit breaker inside, you have to install one breaker outside of it to ensure the safety. Here you can see. And here are two notes, something you have to pay attention to as well. The first thing is the AC output, the N wire and the N1 of the AC input. You should not connect them together or mix them. Usually it will be like this. The L1, the N1, and the G1. And here as well, the L, N, and G. Here is for the inputs. Here is for the output. The N1 here, for the output, you cannot connect them to here. The N1 for the AC output should be here, but not here. If you put the N1 for the AC output to the input, then it will cause a damage to the device, and it will show the default. It will not good for the inverter actually, and it may break the inverter. So you have to pay attention. Do not mix them. The input N wire and the output N wire, don't mix them. And then the second thing you have to pay attention is if the inverter is in parallel mode and there are multiple batteries, do not connect a single battery to a single inverter. So for better understanding, I will draw them out. So here is a inverter, inverter 1, and here is inverter 2. And here we got two batteries. This one is battery 1, and this one is battery 2. Here, do not connect a single battery to a single inverter. What I mean is you cannot connect them together like this. You see, you cannot do this, like connect this and this together, the inverter and the battery together, because they are in parallel. And the batteries are in parallel too. So you cannot do that. It will cause the damage. Then what should we do actually? We should use a copper board. We will connect the batteries to the copper board and then the inverter to the copper too. So they are not connected to each other directly because they are in parallel. We will use the copper. We will connect the inverters to the copper and then the battery to the copper, but not directly from the inverter to the battery. Okay, here are the 2 points very important you should remember because it will cause the damage to the device and break the machine. Okay, thank you guys, all of my friends and partners. We are so happy to have you in this live. Thank you and see you.